Welcome to aminacademy.com. In Discrete Mathematics, let us discuss about assigning probabilities. Assigning probabilities refers to the process of determining the likelihood of various outcomes in an experiment, ensuring that the assigned probabilities satisfy the axioms of probabilities. This can involve approaches such as relative frequency and classical methods to achieve valid probability assignments. Now let us discuss further detail about regarding this assigning probabilities. Assigning probabilities in discrete mathematics involves identifying all possible outcomes in a sample space and assigning a probability to each that sums to 1. That means we have to give different outcomes for different probabilities regarding that sample space, and we'll get the sum of all that particular assigned probability should be 1. The probability of a specific event is found by summing the probabilities of the individual outcomes that make up that event. A simple method is the uniform distribution, where each of the n equally likely to outcomes is assigned a probability of 1 over n. If it is equally likely n number of events, that is a probability of that probability is 1 over n in uniform distribution. Some core principles. Look at the sample space, we can tell as omega. For a coin toss, what is omega? Head and tail. This is the outcomes. That is a sample space, head and tail. For a, this is not outcome, this is a sample space. For a standard 6-sided dice, of course, the sample space is 1, 2, 3, 4, 5, 6. Event A is a subset of the sample space. Out of this, suppose for example, a fair die. For a fair die, the event of the rolling an odd number, of course, it is 3, 5, 3, 1, 3, 5. The sample space is 1, 3, 5. Of course, it is a subset of 1, 2, 3, 4, 5, 6 because our outcome must be an odd number. Probability of an event P of A. The sum of the probabilities of the individual outcome is in event for a die, fair die. Look at here. Suppose here P of A equal P of 1 plus P of 3 plus P of 5. Because of the particular event, this is a probability. P of 1 plus P of 3 plus P of 5 equal to P of A. Sum of the probabilities. The sum of the probabilities for all possible outcomes in the sample space must be equal to 1. This is not all outcomes. This is a particular event, but sum of all outcomes must be 1. Here, this is not 1. P of 1 plus P of 3 plus P of 5 is half only because only odd number here, other even number is missing, so it is half of the sample space. Method for assigning probabilities. Uniform distribution, equally likely outcomes. What is that equally likely outcomes? Because the outcome is 1 over n. N is number of items in a sample space, and the probability of outcome is must be evenly likely is 1 over n. For example, the rolling a fair 6-sided die is there are 6 equally likely outcomes. The probability of rolling a specific number like a 4 is 1 over 6 because there is only 1 4 out of 6 outcomes. So equally likely this 1 over 6. Non-uniform distribution, unequally likely outcomes. For example, it's not a fair die, unfair die means what? Some weight is not balanced every phase. This method is used when outcomes have different probabilities. The probabilities are often determined by real world data or logical reasoning. For example, look at here. A loaded die, that means any phase is uneven. That means weight is not same. P of 1, that is the probability of getting 1 is 1 by 4. P of 2 equal to 1 over 8. P of 3 is 1 over 8. P of 5 is 1 over 8. P of 6 is 1 over 4. Here, P of 1 and P of 6 have equal possibilities, and P of 2, P of 3, P of 5 also another equal possibilities. That means getting 1 and 6 is more chance than to get 2, 3, 5. Now we'll check this with results. This one, look at here. The sum of these possibilities are adding all the fractions here, 1 by 4 plus 1 by 8, 1 by 8, 1 by 8, 1 by 8, 1 by 4 here, totally equal to 1. Now calculating the probability of an event. Here, once you have assigned the probabilities to each outcomes, you can find the probability of an event by adding the probabilities of all the outcomes in that event. Formula P of A equal to sigma A. Sigma A is an element of P of A. For example, for the loaded die above, the probabilities of rolling an even number is P of 2, 4, 6. This is a probability of getting a even number by tossing a die. This is equal to P of 2 plus P of 4 plus P of 6 is 1 over 8 plus 1 over 8 plus 1 by 4 already given. Then it gives half. This is getting a half chance of this P of 2, 4 and 6. Now let us do one more, some simple problem. Look at here. This, what probabilities should we assign to the outcomes of head and tail when a fair coin is flipped? Second question, what probabilities should be assigned when to the outcomes when the coin is biased so that heads comes up twice as often as tails? Here, first chance, that is first is fair die, fair coin. In fair coin, probability of getting H equal to probability of getting tail equal half, because fair coin both equal chances, getting head or tail equal chance. But next one, for biased coin, for unfair, is biased. For unfair coin, look at here. P of H getting head, getting what is the probabilities of should be assigned to the outcomes when the coin is biased so that the heads come up twice as often as tails. That is twice as tail. The probability of tail. Now we know that P of H plus P of tail equal to 1. Here P of H is 2 P of tail plus P of tail equal to 1. Therefore 3 P of tail equal to 1. Therefore P of tail equal to 1 over 3. This side. Then P of H equal to 1 minus 1 over 3, which is equal P of H equal to 2 over 3. That means P of T plus P of H is 1, then we get P of H is 2 over 3. That is 2 times more chance than 2 times more chance for getting H than tail. We have that. Please subscribe our YouTube channel.